NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will factor 3 polynomials and then use those factorizations to find the greatest common divisor and the least common multiple. Here is our example. We will first factor A, then B, then C. After that, we will read the greatest common divisor and the least common multiple from the prime factorizations. Step 1. Factor A. We will use the difference of cubes rule. A cubed minus b cubed equals left parenthesis, a minus b right parenthesis times left parenthesis, a squared plus a b plus b squared right parenthesis. Here, 8y cubed minus 1 is 2y cubed minus 1 cubed. So a equals 5 times 8y cubed minus 1, which factors as 5 times left parenthesis 2y minus 1 right parenthesis times left parenthesis 4y squared plus 2y plus 1 right parenthesis. Step 2. Factor B. Recognize the perfect square trinomial. Left parenthesis, a minus b right parenthesis squared equals a squared minus 2ab plus b squared. So b equals 4y squared minus 4y plus 1. And that is left parenthesis 2y minus 1 right parenthesis squared. Quick challenge for you. Can you predict the full factorization of C? Before we start grouping, pause the video and take a guess. Look for common factors and try grouping. Step 3. Factor C by grouping. We will pair terms and look for common factors, and then factor out left parenthesis 2y minus 1 right parenthesis. Starting from C equals 40y cubed minus 60y squared plus 30y minus 5, we first regroup as left parenthesis 40y cubed minus 5 right parenthesis minus left parenthesis 60y squared minus 30y right parenthesis. Then factor each part, collect the common factor 2y minus 1, and simplify the bracket. The result is C equals 5 times left parenthesis 2y minus 1 right parenthesis cubed. Great. Now we list the prime factors of each polynomial. A equals 5 times left parenthesis 2y minus 1 right parenthesis times left parenthesis 4y squared plus 2y plus 1 right parenthesis. B equals left parenthesis 2y minus 1 right parenthesis squared. C equals 5 times left parenthesis 2y minus 1 right parenthesis cubed. We will read the greatest common divisor using the smallest exponent across the 3, and we will read the least common multiple using the largest exponent across the 3, including every distinct factor that appears. Step 4. The greatest common divisor. The common factor to all is 2y minus 1. The exponents are 1, 2, and 3. So the smallest exponent is 1. Therefore, the greatest common divisor is 2y minus 1. Step 5. The least common multiple. Include every distinct factor with its largest exponent. We need the factor 5. We need 2y minus 1 to the third power, and we also need 4y squared plus 2y plus 1. So the least common multiple is 5 times left parenthesis 2y minus 1 right parenthesis cubed times left parenthesis 4y squared plus 2y plus 1 right parenthesis. Here are the final answers. Greatest common divisor equals 2y minus 1. Least common multiple equals 5 times left parenthesis 2y minus 1 right parenthesis cubed times left parenthesis 4y squared plus 2y plus 1 right parenthesis. Great work! In this lesson, we'll factor 2 polynomials, then use their factors to find the greatest common divisor and the least common multiple. Here is our given pair of polynomials. A quick reminder of the pattern we will use. We can factor a trinomial of the form ax squared plus bx plus c into 2 binomials. Step 1. Factor the polynomial a. We split the middle term negative 2xy as negative 5y times x plus 3y times x, because negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. Then we group and factor to get left parenthesis x minus 5, y right parenthesis times left parenthesis x plus 3y right parenthesis. Step 2. Factor the polynomial b. We split 7x, y as 3y times x plus 4y times x. 3 plus 4 is 7, and 3 times 4 is 12. Grouping gives left parenthesis x plus 3y right parenthesis times left parenthesis x plus 4 y right parenthesis. Now place the fully factored forms together. Notice the common binomial factor. Step 3. The greatest common divisor is the product of the common factors with their smallest powers. Here, the common factor is x plus 3y. So the greatest common divisor of a and b is x plus 3y. Step 4. The least common multiple uses each unique factor with the highest power appearing in either polynomial. Our unique factors are x minus 5y, x plus 3y, and x plus 4y. Therefore, the least common multiple is open parenthesis x plus 3, y close parenthesis times open parenthesis x minus 5, y close parenthesis times open parenthesis x plus 4, y close parenthesis. Quick challenge. In this example, we will factor 4 algebraic expressions and then compute their greatest common divisor and least common multiple. Here are the given expressions for a, b, c, and d. Before factoring, recall a key rule for exponents. Same base multiplied means we add exponents. That is, a to the m times a to the n equals a to the m plus n. Step 1. Factor a. We start with a equals 24 a minus 24b. Factor out 24 to get 24 times a minus b. Now prime factorize 24 as 2 cubed times 3. So a equals 2 to the 3 times 3 times a minus b. Step 2. Factor b. B equals left parenthesis 6 a minus 6b right parenthesis squared. Factor 6 and square. That's 36 times a minus b squared. Write 36 as 2 squared times 3 squared. So b equals 2 squared times 3 squared times a minus b squared. Step 3. Factor c. C equals left parenthesis for a minus 4b right parenthesis cubed. Factor 4 and cube. That's 64 times a minus b cubed. 64 is 2 to the 6. So c equals 2 to the 6 times a minus b cubed. Step 4. Factor d. D equals left parenthesis 9, a squared minus 9, b squared right parenthesis squared. Factor out 9 to get 9 times left parenthesis, a squared minus b squared right parenthesis, then square the whole thing. Use the difference of squares. A squared minus b squared equals a minus b times a plus b. After squaring, 9 squared becomes 3 to the 4, and both binomials are squared. So d equals 3 to the 4 times a minus b squared times a plus b squared. Let's place these factorizations side by side so we can read off the greatest common divisor and least common multiple. Watch how we pick the common factors and the correct exponents. For the greatest common divisor, we need factors common to all 4 expressions, each with the smallest exponent. Notice that 2 does not appear in D, so 2 is not common. 3 does not appear in C, so 3 is not common either. But a minus b appears in all 4 rows. The smallest power among 1, 2, 3, and 2 is 1. So the greatest common divisor is simply a minus b. For the least common multiple, we take every factor that appears in any expression, using the largest exponent among them. For 2, the largest exponent is 6 from C. For 3, the largest exponent is 4 from D. For a minus b, the largest exponent is 3 from C. For a plus b, the largest exponent is 2 from D. So the least common multiple is 2 to the 6 times 3 to the 4 times a minus b to the 3 times a plus b squared. We will factor 3 expressions, find their greatest common divisor, and their least common multiple. This example will connect factoring patterns to greatest common divisor and least common multiple for polynomials. Given 3 expressions, a equals a cubed plus 27b cubed, b equals 5 a squared minus 45b squared, c equals a squared plus 5, ab plus 6b squared. We'll factor each, then read off the greatest common divisor and the least common multiple. Rule reminder: the sum of cubes, a cubed plus b cubed factors as left parenthesis, a plus b right parenthesis times left parenthesis, a squared minus a b plus b squared right parenthesis. Step 1. Factor a using the sum of cubes with b equal to 3b. Next rule: factor out a common constant and use the difference of squares. A squared minus b squared equals left parenthesis, a minus b right parenthesis, a minus b right parenthesis times left parenthesis, a plus b right parenthesis. Step 2. Factor b. Pull out 5, then factor a squared minus 9b squared. Another rule: factor a quadratic trinomial into 2 binomials. Step 3. Factor c. Look for numbers that multiply to 6 and add to 5. That is 2 and 3. Let's visualize the factorizations with factor tiles, so common pieces pop out clearly. Notice the binomial a plus 3b appears in all three, so it must be part of the greatest common divisor. Step 4. The greatest common divisor is the product of all common factors with the smallest powers across a, b, and c. Here, the only common factor is a plus 3b. So the greatest common divisor of a, b, and c equals a plus 3b. Step 5. The least common multiple includes every unique factor with the largest power that appears in any expression. Collect 5. Multiple includes every unique factor with the largest power that appears in any expression. Collect 5. A plus 3b, a minus 3b, a plus 2b, and the quadratic a squared minus 3ab plus 9b squared. So the least common multiple is 5 times a plus 3b times a minus 3b times a plus 2b times a squared minus 3ab plus 9b squared. Final answers. We have 3 bells that ring at different intervals in a factory. The first bell rings every 18 minutes, the second bell rings every 24 minutes, and the third bell rings every 32 minutes. After they ring together once, how many minutes must pass until they ring together again? This is a classic least common multiple problem. The least common multiple is the smallest number that is divisible by all the intervals. Step 1. List multiples and look for the first common one. We'll write the first few multiples for each. The first common number on all 3 lists will be the least common multiple. Step 2. Use prime factorization to compute the least common multiple efficiently. We'll build factor trees for 18, 24, and 32. Then summarize each as powers of primes. Step 3. Take the highest power of each prime that appears. We need 2 to the 5th and 3 squared. 2 to the 5th is 32. 3 squared is 9. Multiply them to get 288. So after they first ring together, they will all ring together again after 288 minutes. In this example, we want to pack 72 liters of fruit juice, 40 liters of milk, and 48 liters of yogurt into bottles of equal volume. The bottle volume must be a whole number of liters. What is the minimum number of bottles needed? We'll solve this using the greatest common divisor idea. Let's visualize the 3 liquids. We'll color fruit juice in orange, milk in blue, and yogurt in green. Each tank is labeled with its total liters. To minimize the number of bottles, we want the largest possible bottle volume that divides all 3 totals exactly. That largest shared divisor is the greatest common divisor. One way to find it is by prime factorization. Let's factor each number. 72 equals 2 to the 3rd times 3 squared. 40 equals 2 to the 3rd times 5. 48 equals 2 to the 4th times 3. The common part is 2 to the 3rd. So the greatest common divisor is 8. Now divide each total by 8 to get the number of bottles. For juice, 72 over 8 equals 9 bottles. For milk, 40 over 8 equals 5 bottles. For yogurt, 48 over 8 equals 6 bottles. Let's see what that looks like. 9 bottles for juice, 5 bottles for milk, and 6 bottles for yogurt, all with 8 liters each. Add them up for the total minimum number of bottles. 9 plus 5 plus 6 equals 20 bottles. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.